Hello guys, I welcome you all to my channel Engineers Academy. Do subscribe my channel if you haven't done it yet. Now let's solve this particular problem which says that the uniform panel door weighs 60 pounds and is prevented from opening by strut C, which is a light two force member whose upper end is secured under the door knob and whose lower end is attached to a rubber cup which does not slip on the floor. And it is said that of the door hinges A and B, only B can support force in the vertical Z direction. Calculate the compression C in the strut and the horizontal components of the forces supported by hinges A and B. When a horizontal force P 50 pounds is applied, normal to the plane of the door is shown. So here we have this door which is prevented from rotation by this strut C, which is acting from this particular point to that knob, and this P is applied which has a magnitude of 50 pounds and it is perpendicular to the plane of the door, and all the dimensions of the door and the location of these A and B hinges are given. And further it is said that only this hinge B can support the vertical the reaction in the Z direction. So now if we represent all those reactions, so let's say first of all if we observe this, so this is our positive x-axis, this is our positive y-axis, and this is our positive z-axis, and we remember that the thickness of the door is assumed to be negligible, right? So first of all, if I show the reactions at A, so we will have a x reaction, let's say, which will be, let's say it is acting in the positive x direction, and we will have the AY reaction which will be parallel to the y-axis. This is AY, and there is no AZ reaction since in the problem statement it is said that only B can support the reaction in the Z direction. So at B we will have BX, here we will have BX, and we will have BY. Let's say this is BY, and we will have BZ which is acting in the positive Z direction. Let's say this is BZ. And similarly the weight of the door must be acting at the geometric center of the door. So the weight of the door is the line of action of the weight of the door is passing through the geometric center of the door. So this is the weight and its line of action must be passing through the geometric center. So this is that point, this is the center of gravity of this door, which is the intersection of these two lines, these two dashed lines. So, and the strut C is going to apply the force. So first of all we have to find the Cartesian vector representation of this strut C force, which is acting in this direction. The strut is going to apply the force in this direction. So this is, let's say, C. So we have to find the Cartesian vector representation of this C force. So this C vector, this will be equal to C times the unit vector, and the unit vector must be acting from this particular point to this particular point. So let's say that that this point is P, and let's say this point is Q. So now we have to write that the unit vector from P to Q, or we can write that the unit vector from P to Q is the position vector from P to Q divided by magnitude of that position vector. And now to find the position vector from P to Q, we need to travel from point P to reach that point Q. So from point P we need to travel this distance, which is 30 inches, and this is in the negative y. So I will write minus 30j, and then once I reach here, then I need to travel this distance, which is 40 inches in the positive z. And as we can see that point P is at a distance of 8 inches and point Q is at a distance of 8 inches. So this position vector from P to Q has only two components, which is in the y and z direction. So then we need to travel 40 plus 40 inches in the positive k direction. So this is the position vector from P to Q, and then its magnitude will be 30 square plus 40 square under the square root, and 30 square plus 40 square, this comes out to be 50. So now we can write that Cartesian vector representation of that compression in the strut C is C, and we can write that this is minus 30 divided by 50 J plus 40 divided by 50 K, and we can multiply the C inside, so we will have like this. And now we can simplify this. This is C vector, and 30 divided by 50 will give us 0.6, so this is minus 0.6 Cj, and then 40 divided by 50, this gives us plus 0.8 K. So this is the, and 0.8 C into K, right? Remember, this is 0.8 C and K. So from this we can conclude that C has only two components. This is one component in the Y direction, and this is one component in the K direction. So now let's remove this C, and now let's show its components. So C has two components. One is, this one is CY component, and this one is CZ component. So CY component must be acting in the negative Y, since we have minus sign here. So we will have, let me show that this is CY, this is acting in the negative Y, and we have CZ. And once we know C, we can find CY magnitude. CY magnitude is 0.6 C, and CZ magnitude is 0.8 C. Now to find the C, since in the problem statement it said that calculate the compression C in the strut. So first of all, I am going to find the C. So for that, I am going to apply the summation of the moment about the hinge axis, that is AB axis. That must be equal to 0, since the door is in equilibrium, it is at rest. So we are going to find the moment about the hinge axis, this axis, this is AB. So as we can see that all the reactions at A and B, they are passing through the hinge axis, so they are not going to come into our equation. And this weight is parallel to the hinge axis as well, so it's not going to come into our equation, since it's not going to produce the moment about the hinge axis. Similarly, this CZ, this is also parallel to the hinge axis, so it's not going to produce the moment about the hinge axis. So only CY and this P force is going to produce the moment about the hinge axis AB. So now if we look into this P force from the top, so it's going to produce the moment about the hinge axis in this direction. And if we curl our right hand fingers in this direction, so the thumb will point out in the upward direction. So let's say that the moment about AB in the upward direction is the counterclockwise moment. So from this we can conclude that P is producing the counterclockwise moment about the hinge axis. So I will write plus P, and the perpendicular distance of this P from that hinge axis is this distance. So this distance is 48. So this is P into 48. And then CY is producing the moment in this direction about the hinge axis. And if we curl our right hand fingers in this direction, let's say that this is my AB axis. So the CY is producing the moment about AB axis in this direction, like this. And if we curl our right hand finger, so the thumb will point out in the negative AB direction. So this means that CY is producing the clockwise moment, right? So I will write CY, and again the perpendicular distance of CY from that hinge axis is this distance, which is 48 minus 8, which is 40. So I will multiply this with 40. So this must be equal to 0. And as you people can see that we are applying the F into D. This is force times the perpendicular distance, So from this I should remind you people that I am solving this problem by the scalar method, that is the moment is equal to F into D. Now from this equation we can write that CY is equal to P into 48 divided by 40, and in the problem statement it is said that P is equal to 50. So now we can replace this P by 50. So this is 50 into 48 divided by 40. So 50 into 48 divided by 40, this gives us 60. So CY equals to, this is equal to 60 pounds. And now from here we know that cy magnitude is 0.6 c, so I can write that cy is equal to 0.6 c equals to 60 pounds. And similarly from this we can find that c value, which is 60 divided by 0.6, and this will give us c equals to 100 pounds. So this is the compression c in the strut, which is equal to 100 pounds. Similarly, once we know the c, we can find cz. So let me write that cz is equal to cz magnitude is 0.8 times c, so I will write 0.8 into 100, so this will give us 80 pounds. Cz is 80, right? So 0.8 into 100 is 80 pounds. So this is cz. So now we know cy magnitude. Let me write that this cy magnitude is 60, so I can write that this is 60 and cz is 80. So c 60 pound and cz is 80 pounds. Now to find the horizontal components of the reactions supported by hinge A and B, I am going to find the moment about point B. Let's say at B we have this x dash axis, and similarly at B we have y dash axis, right? We have defined another coordinate system at B. So now to find a x and a y, we are going to apply the summation of the moment about the x dash axis, that will be equal to 0. So now remember that all the components which are parallel to the x-axis or the x dash axis, they are not going to produce the moment about the x dash axis. So now as we can see that this ax, this by, bx and bz, they are passing through the x dash axis, so they are not going to produce the moment about the x dash axis. Similarly, this cz is passing through that x dash axis, it's not going to produce the moment about the x dash axis. And this weight is passing through that x dash axis, so it's not going to produce the moment about the x dash axis. So only a y, cy and this p force, they are producing the moment about the x dash axis, since they are perpendicular to the x dash axis, right? Since they are acting along the y axis, the cy, ay and p. So now from this, if we look into this ay, so it's going to rotate the whole system about the x dash axis in this direction, like this. And if we curl our right hand fingers in this direction, so the thumb will point out in the negative x dash direction. So this means that ay is producing the clockwise moment, so I will write minus ay, and the perpendicular distance of this ay from that x dash axis is this distance, which is this total distance, this 80 minus 8 minus 8. This is 80 minus 8 minus 8. So this is 64. So I will multiply this ay with 64. The perpendicular distance between hinge A and B is 64. So I will multiply this with 64. Similarly, cy is producing the moment about the x dash in this direction. And if we curl our right hand fingers in this direction, so the thumb will point out in this direction. So this means that it is producing the counterclockwise moment. So I will write plus, and cy magnitude is 60, and the perpendicular distance of cy from that point, from that x dash axis is this distance, and this distance is 40 minus 8. So the perpendicular distance of cy from x dash is 40 minus 8, which is 32. And similarly, this p force is producing the moment about the x dash axis in this direction, like this. And if we curl our right hand fingers in this direction around the x dash axis, so the thumb will point out in the negative x dash direction. So this means that p is producing the clockwise moment. So I will write minus p, and p has a magnitude of 50 pounds. So I will write 50 into the perpendicular distance from the x dash axis. So the perpendicular distance is this distance. So this is the total 80 distance minus 8. So the perpendicular distance of p from the x dash axis or from hinge B is 72. So this is equal to 0. So now from this we can write that minus ay into 64, this is equal to minus 60 into 32 plus 50 into 72, or we can say that this is AY is equal to this thing, right? So this will give us AY. So this is minus 60 into 32 plus 50 into 72 divided by minus 64. So AY equals to minus 26.25 pounds. So now the negative sign tells us that the assumed direction of AY is not accurate, it is acting in the opposite direction. So this means that AY, since we have assumed that AY is acting in the positive Y direction, but it is acting in the negative Y direction since its magnitude is negative and its magnitude is 26.25 pounds. Now to find AX reaction, we are going to apply the summation of moment about the Y dash axis, that must also be equals to 0. So now let me write that the summation of the moment about the Y dash axis, that will be equal to 0. So now remember that since we are going to find the moment about the Y dash axis, so all the components that are parallel to the Y axis, they are not going to come into our equation. They are not producing the moment about Y dash axis since they are parallel to the Y dash axis. So only the X component and the Z components are going to come into our equation. And as we can see that since this Y dash axis is passing to this point B, so all these reactions, the reactions at B are not going to come into our equation as well. So as we can see that this X is going to produce the moment about the Y dash. This is not going to produce the moment about Y dash since it's parallel to the Y dash axis. Similarly, this CZ is going to produce the moment about the Y dash axis. This CY is parallel to the Y dash axis. It's not going to produce the moment about the Y dash axis. And the weight is going to produce the moment about the Y dash axis since it's acting along the Z axis. So only the X component and the Z components are going to produce the moment about the Y dash axis. So now as we can see that AX is going to produce the moment about the Y dash axis in this direction, like this. And if we curl our right hand fingers, so the thumb will point out in the positive Y dash direction. So this means that X is producing the counterclockwise moment. So I will write plus AX, and the perpendicular distance of AX from the Y dash is again this distance, the distance between A and B, and the distance between A and B is 64. That is 80 minus 8 minus 8, so that is 64. So I will multiply AX with 64. Similarly, this CZ is producing the moment about the Y dash axis in this direction, and if I curl my right hand fingers in this direction, so the thumb will point out in the negative Y dash direction. So this means that it is producing the clockwise moment. I will write minus, and CZ is 80, and the perpendicular distance of CZ from Y dash axis is this distance, which is this distance minus this. So this distance is 48 minus 8, so this is 40. So I will multiply this with 40. Similarly, the weight is going to produce the moment about the Y dash axis. The weight is going to produce the moment about the Y dash axis in this direction. And again, if I curl my right hand fingers in this direction, so the thumb will point out in the positive Y dash direction. So this is producing the counterclockwise moment. So I will write plus, and the weight is 60 pounds. Let me write that this weight is 60 pounds. So the weight is producing the counterclockwise moment. So I will write 60, and the perpendicular distance of this weight from the Y dash axis is this distance, which is half of this, is 48 divided by 2, which is 24. So I will multiply this 60 with 24, and this will be equals to 0. So now from this we can write that AX is equal to 80 into 40 minus 60 into 24 divided by 64. So this will give us AX. So this is 80 into 40 minus 60 into 24 divided by 64. So AX is equal to 27.5 pounds. Now the resultant reaction at A is, we can find the magnitude of the reaction at A, that will be equal to ax square plus ay square, and this resultant reaction will lie in the xy plane. It will lie in the xy plane like this, right? So this is that reaction which will be the summation of ax and ay. So if we add ax and ay, so it must be acting in this direction, and its magnitude will be ax square plus ay square. So now ax is known. This is ax, which is 27.5 pounds. So this is 27.5 square plus ay square, which is 26.25 square. So this gives us the resultant reaction at A equals to 38 approximately. So A is equal to 38 pounds, and this is acting in the xy plane. Remember, in the problem statement it said that find the horizontal components of the forces supported by hinge A and B. So this component is horizontal. It is lying in the xy plane. Similarly, to find bx, by, there is no need to find bz, since we are required to find the resultant reaction in the horizontal direction. So we have to find bx and by, and we have to find the magnitude of bx and by, and that will give us the horizontal component of the reaction at B. So now for that we are going to apply the summation of forces along x, that will be equal to 0. So for that, let me copy this figure. Now the weight is 60 pounds. Let me write it here. Now the summation of forces along the x-axis is that must be equals to 0. So now ax is acting in the positive x direction. This is ax. So we will write ax magnitude is 27.5 pounds. Similarly, this is bx is not known. It is acting in the, let's say it is acting in the assumed direction is in the positive x direction. So we will write bx plus ax, and that must be equal to 0 since there is no other force in the x direction, right? So bx is equal to minus 27.5 pounds. So the assumed direction of bx is not accurate. Bx is acting in the negative x direction, and its magnitude is 27.5 pounds. Similarly, if we apply the summation of forces along the y direction, that must be equal to 0. So again we will write by is acting in the positive y direction, plus ay, but the ay magnitude is this is minus. We have assumed that ay is acting in the positive y direction, but from the answer we get that it is acting in the negative y direction. So I will write that this is minus 26.25, and similarly cy, this cy is acting in the negative y. So I will write minus, cy magnitude is 60, and similarly this p force is acting in the positive y direction. Its magnitude is 50. So I will write plus 50, and this is equal to 0. So from this we can write that by is equal to 60 minus 50 plus 26.25. So this will give us 60 minus 50 plus 26.25. This gives us 36.25. So by equals to 36.25 pounds. So now the horizontal reaction at B, that the reaction at B acting in the xy plane will be equal to, the magnitude of that will be equal to bx square plus by square under the square root. So now we know bx is 27.5 square plus by, which is 36.25 square. This gives us b equals to 45.5 pounds, and remember that it is acting in the xy plane. So this is the horizontal component of the reaction at B lying in the xy plane. This is the horizontal component of the reaction at A, which is acting in the xy plane, and the compression in that strut is equal to 100 pounds. So this is the solution of this particular problem. I hope this will help you in your learning.